evening, my fellow chemistry enthusiasts. This is Montfort ChemPath, and today we will be looking at part two of the mole concept series. And today's topic will be covering balancing chemical equations. So, balancing chemical equations is a very important topic, especially when we're looking at the mole concept. Right? And when we speak of balancing chemical equation, we're basically making sure that the number of atoms of each element is the same on both sides of a chemical equation. So there are a couple key terms that you should be acquainted with when we're looking at balancing chemical equation. The first one is the law of conservation of mass. Right? So this is basically in a chemical reaction, mass is neither created nor destroyed. So think of a Lego blocks, right? And the Lego blocks is the atoms. So you can rearrange the Lego blocks and build whatever you may like. But in reality, you cannot create the Lego blocks and you cannot destroy them. So it's the same principle apply when we're talking about conservation of mass, right? The atoms may be rearranged in a chemical equation, but the mass is the same. It's neither created nor destroyed. And a chemical equation is a symbolic way of showing a chemical reaction using formulas. For example, let's say we have the reaction of water. Alright, we have H2, which is hydrogen, bonding with, right, reacting with oxygen, both in the gaseous form, to give us H2O. So this is a perfect example of a chemical equation where we use a symbolic way. We use H to represent hydrogen, O to represent oxygen, right? And we could see the formation of water, H2O. Alright, good. So there are some key things or some important steps we should take when we about to balance a chemical equation. So let's go through them together. For example, let's say we have the same formation of water, which is H2 gas plus O2. Alright, the first thing we should do is to count the amount of atoms on each side of the equation. So we know on our left hand side is the reactants, on our right hand side is the products. So how many how many atoms of hydrogen we have on our right hand side? We could use two, right? Alright, it is two. We're gonna denote this by using dots. So we have two hydrogen on the reactant side. Also, we have two oxygen on the reactant side. But if we come on the product side, how many hydrogen we have? We also still have two. But we only have one oxygen atom on the product side. So in order to balance this chemical equation, what we do is first we add something called coefficients in front of the symbol. We cannot remove the subscripts of the chemical chemical equation, right? We simply add coefficients in front of the symbols. So we see that the majority of the atoms is 2 each. So if we add a 2 in front of the water, the H2, that means now instead we don't have 2 hydrogen, but we have 4. And a key thing to note is we don't add the coefficient and the subscript of the atom, but we multiply them. So we say 2 times 2 is 4 rather than 2 plus 2 is 4. Alright, and this 2 is governing every single atom in this molecule. So we have 2 times 2, which is 4 hydrogen, and we'll have 2 oxygen. So now we have 2 oxygen, right? Balancing off the oxygen. But however, since we balance off the oxygen, we still have 4. We now have 4 hydrogen atoms to 2 hydrogen atoms on the reactant side. We could simply add a 2 in front of the hydrogen in front of the hydrogen on the reactant side, and then this reaction will be balanced. So in a whole general sense, it's basically putting coefficients in front of the different compounds or atoms within a chemical equation to make it balance on both sides of the reaction, which again comes back to the law of conservation, of mass. Let's look at a few more practical examples before we look at the importance on why balancing chemical equations is important in calculating moles. So let's say we have the reaction or the formation of salt. We have sodium chloride, Cl2 gas will give you NaCl. Alright, and this is the salt that we use in cooking. Alright, so all the food lovers out there, all the cooks out there, alright, this is the chemical equation of the salt you'll be using, which is sodium chloride. And the first thing we need to do is to count how many atoms on both sides of the equation. So we have 1 sodium on the reactant side, we have 2 chlorine on the reactant side, and on the product side we also have 1 sodium to 1 chlorine. So the sodium is balanced, but the chlorine is not balanced. So again, we add coefficients in front of the atom to make it balanced. So if we add a 2 right in front of the NaCl, it will now become 2 sodium and also 2 chlorine. So now we balance the chlorine, but now we made the sodium imbalance. And to make this balance, we simply added 2 in front of the sodium on the reactant side, and then it will be balanced. Right? A key thing to note is that not all the time we will be using 2. Right? Sometimes you may find some equations, some complex equations may find you using 3, 4, or what's not. But the key thing to know that we use coefficients. We use coefficients to balance a chemical equation, and we use the smallest one possible, right? Because we want the smallest ratio possible. Let's look at this last one. So you have Zed, you have zinc reacting with hydrochloric acid, and that reaction will give you zinc chloride plus hydrogen gas. So if we examine this equation, we can see that the hydrogen is in balance. All right, there's one hydrogen on the reactant side and two over on the product side. So we simply balance the hydrogen by adding a 2 in front of the HCl or the hydrochloric acid. And I missed out a 2 for the zinc chloride, the superscript, because the correct chemical formula is ZnCl2. So the chlorine was also imbalanced. But when we add the 2 in front of the HCl, it made the chlorine and the hydrogen balance on both sides of the reaction. This is a balanced equation. Now, why this is important to moles? Why does balancing equation matter for moles? So when we balance chemical equation, it gives us mole ratio. You know, a balanced chemical equation tells you the mole ratio between substances. So for example, let's use um or let's use water. Alright. So the coefficients in front of the atoms we're gonna use to represent how much moles react to what. So the mole ratio or the mole ratio between, let's say, what is the mole ratio between hydrogen and water, right? So this here is 2 moles of hydrogen reacting with to form 2 moles of water. So that is how we do a mole ratio, right? If they ask what was the mole ratio between hydrogen and oxygen, then in this case it would have been 2 moles of hydrogen reacting with 1 mole of oxygen. Right? We use the coefficient to symbolize how much moles react to how much, because there's no coefficient in front of oxygen, and we know in mathematics when there is not where a coefficient is not in front of a variable, it signifies that it's 1, right? So why mole ratio are important in chemistry? We do not measure atoms directly, we use moles, right? Because atoms are very tiny, it is hard to count, so we use moles as a unit or a larger unit to calculate it. Let's say, for example, to count rice grains, right? We won't count the individual rice grains bit by bit to know how much rice grains we need to cook. Rather, we may use cups or pint cups to scoop them out and have a more accurate and larger unit of counting. Right? So the same principle applies. So your balanced chemical equation to allow you to convert moles of one substance to another, it predict the products that is formed, and it calculate how much reactant is needed. Example, if you have 2 moles of H2, how many moles of H2O form? So we could go back to our example when we have the formation of water. If it's 2 moles of H2, how many moles of H2O form? Right, so we have to look at H2 and then we have to look at H2O. Right, and 2 coefficients behind those 2 is 2 to 2. So the mole ratio is 2 to 2. 2 moles of hydrogen, right, forms 2 moles of water. Alright, so these are some tips for students. Remember the law of conservation. Count the atoms carefully before adding coefficients and write the correct formulas first. Never change the formulas while balancing. And this brings the curtains down to today's topic. I hope you find it useful. I hope you enjoyed today's session. Leave a like, leave a comment, subscribe to the channel for more videos and more teachings on mole concept and chemistry in a whole. If you're seeking help, right, or you know someone that is seeking help and want to further their studies in chemistry, I tutor chemistry online for C-Sex students. You could hit me up on the number below. Um, I know it's around exam times and you guys need an extra push. I will make myself available because it is at my best interest that you guys excel and succeed in your exams. Thanks again for watching. You do have a blessed day.